Right, 2B really is a very hard question. The examiner's report did say that not many students had much success with this, but we'll give it a go. So you do need to have read the datasheet carefully and have spotted the bit that's highlighted here in yellow that tells you how to calculate the angle of inclination. Okay, so that's just straight from the datasheet. And then you really need to spot that the change in vertical height over the change in horizontal distance is really just saying the gradient. Okay, and the key is because it says for a small time interval, we'll find that value of the gradient through differentiating. Okay, so you've already found dh dx, you found that in question 1. Okay, so you've got 3x squared minus 24x plus 36 from question 1, and they want to know what's happening when it's immediately above point 0. So that's when it starts. Okay, so that's when x is 0, when its horizontal distance is 0. Okay, so dh dx. So if you substitute 0 into dh dx, you actually just get the value of 36. Okay, but even then we've still got to think very carefully because h is in meters and x is in hundreds of meters. So actually to get the real life value for the gradient, we really need to divide that through by 100. Okay, now if you didn't spot that, you do still pick up quite a few marks for this question if you use a value of 36. Okay, but there's a lot to think about here. If you do get that far though, it's quite easy to finish off because as it says here, as given in the data sheet, tan alpha is the value of the gradient. Okay, so all you then need to do is inverse tan that value, and that will give you your value for alpha. Okay, and just to be on the safe side, let's make sure I'm clear that that is my final value for alpha.